Our essential question for this video is, what are the names of the parts of a quadratic function graph? And I know that your temptation now, class, is you can see a bunch of them. You can just frantically start to write these all down. Please just stay with me. Spend the time as we talk through each of these. You're going to get some valuable information, hopefully, instead of just copying down a whole bunch of definitions that you're not going to remember. So let's take a look here. I have an example, just an example of a quadratic graph. You can see it's graphing as a parabola. And actually that's our first definition, and that is, what is a parabola? And a parabola is the shape made by the graph of a quadratic function. So you take any quadratic function and you graph it, it's going to be the shape of a parabola. Next definition is, what is a vertex? Oh, by the way, just pause the video, finish writing that, and then continue on. Okay, vertex, the lowest or highest point on the parabola. Let's go ahead and label over here for this particular parabola. Let's put a point right here. Make it big enough where you can see it. And I'm going to go ahead and draw an arrow from that. And let's go ahead and label that as the vertex. Now notice it says it can be the highest or lowest point. If the parabola faces up, the vertex will be the very lowest point on the parabola. If the parabola faces down or opens down, it will be the highest point. All right, axis of symmetry. You'll see me abbreviate that as AOS, so I don't have to write the whole thing out. Remember, symmetry last year. Symmetry means that a shape has a reflection. Maybe the left and right sides are reflections of each other, or the top and bottom. So there is a line of symmetry on a particular shape. A parabola has an axis of symmetry. It's a vertical line that goes through the vertex and divides the parabola into two reflected halves. And you'll see, class, that no matter how we draw this parabola, you're going to be able to take a vertical line. Let's pick a different color. And we're going to draw down vertically through. I'm going to do my best to stay on that line if I can. Draw a line through. Oops, that one's a little bit off. I'm going to go through the vertex. And you can see that particular line, if I draw that all the way through, that line passes through the vertex. It's a vertical line. You know what? Let's do this. I want to make this a little bit neater for you. Let's actually just draw a line. I'll put a line through there the best I can. Can I make it straight? All right, it's pretty good. Let's slide it a little bit over so it's actually on our vertex. Oops, that's not working. I don't know why that's doing something weird like that. Let's see if we can make it go away. All right, there we go. And I'm going to go ahead and let's just erase a few spots. It looks like it's a dashed line. That's much better. So there we go. There is an example of an axis of symmetry. Goes through the vertex. And let's go ahead and label that. We'll still keep that as light blue. And I'm going to label that up here. That is our axis of symmetry. Okay, axis of symmetry. And now just one more thing is put in definition. It's going to be an equation that is x equals some number, and that number is going to be the x value of the vertex. So in this case, our axis of symmetry is actually x equals -2, because on this line, x is always -2. You look at this point, x is -2. Look at this point down here, x is -2. So this axis of symmetry, I'm going to actually define that right here. X equals -2. All right, next one, Y-intercept, the point where the parabola touches the y-axis. There will always be one Y-intercept. No matter where your parabola is drawn on the graph, you may not even see the y-intercept. It may not be on your graph, but eventually the parabola is going to touch the y-axis. So here's where we touch the y-axis, and that we're going to go ahead and let's label that over, how do I want to do this? Let's put it right below this. Okay, and I'm just going to abbreviate this as the Y-Intercept. Y-INT is good enough so we know we're looking at the Y-intercept. Where does the parabola touch or cross the y-axis? Okay, X-intercept. The point or points, notice I have a plural, point or points where the parabola touches the x-axis. A quadratic can have 0, 1, or 2 x-intercepts. Notice on this graph, we actually have 2 x-intercepts. We've got one right here at about 0.5 is pretty close. We got one here at about, let's see, 1, 2, 3, about 4.5, estimate. This parabola has 2 x-intercepts. Some parabolas will only touch the x-axis at one place if the vertex is on the x-axis. Some parabolas, think about this, if this parabola is right here, notice that parabola will never touch the x-axis. So a parabola can have 0, 1, or 2 x-intercepts. Let's go ahead and label these here. So I'll put an arrow here. Let's pick up this arrow here. And we're going to call those the X-intercepts. Okay. Next thing, minimum or maximum. When you see those words, here's what they mean in this unit. If the parabola opens up, meaning it faces kind of like, it's like a bowl that can hold some water, so it's facing up, the vertex is a minimum point. Notice it's going to be on the bottom of the parabola. It's the lowest or smallest value of y. If the parabola opens down this direction, then you see the vertex is the highest point or the largest y value. In this case, you should see the parabola faces up. That means the vertex is a minimum point. All right? Now, here's 2 words you learned last year, and maybe a lot of you forgot these. Let's revisit these so you remember. Domain. The domain is the set of all possible x values for the function. The domain for a quadratic is always all real numbers. Now, here's the reason why. If the domain is a set of all possible x values, when you look at this parabola class, you have a tendency to think that as this graph continues further and further, eventually these 2 arrows are going to be straight up and down. And the fact is, that's not true. This parabola will continue to get wider and wider and wider the longer it goes up, the farther it goes up. Now, it may get wider at a slower and slower pace, but it will never stop getting wider. And that means you draw this parabola 50 miles high, you're going to see that you've got a pretty big range of x values. You draw it 50 million miles high, you're going to get an even wider range of x values. And if you draw it to infinity, you'll pick up every x value. So the domain is always going to be all real numbers. And we usually just write that as, excuse me, what I was going to say here, if I ask you what the domain of any quadratic is, you're just going to write all real. All real. Or you can put all real numbers. All right, now range is different. The range is a set of all possible y values for a function. If the parabola faces up, the range is going to be y is greater than or equal to the y value of the vertex. That means, look at our y values here. They're going to be this point right here, the y value of this point, which is -3, and every number above that value is going to be represented on this graph. Because look, we've got y equals here is -2, -1, 0, 1, 2, 3, 4, keep on going with the arrow, 5, 6, 7, to infinity. So if the parabola faces up, the range will be y is greater than or equal to the y value of the vertex. If the parabola faces down, the range is going to be y is less than or equal to the y value of the vertex. So in this case, the range in this particular question is actually going to be, we have a parabola that faces up. So in this case, our range is going to be y is greater than or equal to, and now look, our y value of our vertex is -3, so greater than or equal to -3. In fact, let's go ahead and write our domain as well, since we know it's always going to be all real. And you know what? Let's go ahead and define our vertex right now too. So our vertex here, you can see, is equal to the coordinates. Let's see, here's 0, 0. We got to go -2 to the left and -3 down. So -2, -3. Our x-intercepts and our y-intercepts, we can take a guess at what those are. We can estimate those, but we don't know those exactly. Well, let's go ahead and write those down. Here, our y-intercept, it looks like it's approximately, let's use the approximate symbol. It's like an equal sign with wavy lines. It's approximately, let's say 1.25. And our x-intercepts are going to be at about, let's call that 0.5. And I'll put a comma there. Let's make that a 0 so you can see it's a 0. And it looks like it's 1, 2, 3, 4, about -4.5. So we can look at a graph and either we know the exact value, like in this case, we know the vertex is exactly on the graph, it's whole numbers, but the y-intercept and x-intercepts, we can estimate those from a graph if we don't calculate them exactly. All right, so there are the names of the parts of a quadratic function graph that you need to understand well.